Affinity propagation clustering. This system utilizes the affinity propagation algorithm from sklearn to perform clustering on input data. The architecture comprises the following key components. Represents the dataset to be clustered, consisting of features or attributes that describe each data point. Provides the raw data for the clustering process. A matrix that quantifies the similarity between pairs of data points. Each entry represents the similarity between 2 points. Defines the relationship between data points and informs the clustering algorithm. A matrix that specifies the preference for each data point to be a cluster center. Higher values indicate a stronger preference. Guides the selection of cluster centers. The core algorithm that performs the clustering based on the similarity and preference matrices. Executes the iterative affinity propagation algorithm to find the optimal cluster assignments in centers. The final set of data points that are identified as cluster centers by the algorithm represent the representative points for each cluster. A label assigned to each data point, indicating which cluster it belongs to based on the algorithm's output. Provides the final clustering results, assigning each data point to a specific cluster. Affinity propagation. The raw input data is passed to the affinity propagation algorithm. Affinity propagation. The similarity matrix, capturing the relationships between data points, is provided to the algorithm. Affinity propagation. The preference matrix, indicating the preference for each data point as a cluster center, is input to the algorithm. Cluster centers. The algorithm produces the final set of cluster centers based on the provided input. Cluster labels. The algorithm generates the cluster labels, assigning each data point to its respective cluster. Birch clustering algorithm. Data preparation. Loads the raw data and performs necessary preprocessing steps, such as scaling or normalizing features. Data loader. Loads the dataset from a specified source. Receives raw data as input. Preprocessed data. Preprocessor. Scales or normalizes features to ensure consistent scales across features. Receives data from the data loader. Preprocessed data. Birch tree construction. Builds a hierarchical tree structure CF tree that efficiently represents the data. CF tree builder. Constructs the CF tree based on the preprocessed data. Receives preprocessed data. CF tree. CF merger. Merges similar CFs based on a threshold T to form larger subclusters. Receives CF tree and threshold value. Updated CF tree. Cluster refinement. Refines the clusters obtained from the CF tree using an agglomerative clustering algorithm. Global clustering algorithm. Applies an agglomerative clustering algorithm e.g., k-means to the CFs to determine final clusters. Receives CF tree. Final clusters. Cluster number controller. Specifies the desired number of clusters k for the final output. Receives number of clusters k from the user. Number of clusters k. The overall system focuses on performing HDBSCAN clustering on input data. Input data. Raw data to be clustered. Provides the starting point for the clustering process. Data. Preprocessing. Optional step to prepare the data for clustering. Scales, standardizes, and/or reduces dimensionality of the input data. Data. Preprocessed data. Density estimation. Calculates the density of data points in the feature space. Identifies regions with high data concentration. Preprocessed data. Density map. Cluster hierarchy construction. Builds a hierarchical representation of the data based on density. Organizes data points into nested clusters based on their density relationships. Density map. Cluster hierarchy. Cluster extraction. Extracts flat clusters from the hierarchical representation. Selects the most meaningful clusters based on stability and significance. Cluster hierarchy. Clusters. Cluster labeling. Assigns labels to the extracted clusters. Provides a clear identification for each cluster. Clusters. Cluster labels. Output clusters. The final clustered data represents the grouped data points, providing insights into the underlying structure of the input data. Cluster labels. Clustered data. The core component responsible for identifying and grouping related features in the input data. Input data. Unprocessed data containing various features. Output data. Transformed data with features grouped based on their relationships. Affinity propagation. Passes grouped data to the affinity propagation clustering algorithm. Agglomerative clustering. Passes grouped data to the agglomerative clustering algorithm. Birch. Passes grouped data to the Birch clustering algorithm. K-means. Passes grouped data to the K-means clustering algorithm. Mini-batch K-means. Passes grouped data to the mini-batch K-means clustering algorithm. Mean shift. Passes grouped data to the mean shift clustering algorithm. Optics. Passes grouped data to the optics clustering algorithm. Spectral clustering. Passes grouped data to the spectral clustering algorithm. DBSCAN. Passes grouped data to the DBSCAN clustering algorithm. The raw, unprocessed data that serves as input to the feature agglomeration component. The output of the feature agglomeration component, containing grouped features. This data is further processed by the clustering algorithms. Represents the output of the clustering algorithms. It describes how features are grouped based on their similarity or proximity. Represents the number of clusters identified by the clustering algorithms. This parameter is determined by the algorithm and influences the granularity of the feature grouping. A clustering algorithm that uses a message passing approach to find clusters. It takes the grouped features from feature agglomeration as input. A hierarchical clustering algorithm that progressively merges clusters based on their similarity. It takes the grouped features from feature agglomeration as input. A clustering algorithm that builds a hierarchical clustering tree from the input data. It takes the grouped features from feature agglomeration as input. A centroid-based clustering algorithm that partitions data into K clusters based on their distance. To cluster centroids, it takes the grouped features from feature agglomeration as input. A variation of K-means that handles large datasets by processing data in mini-batches. It takes the grouped features from feature agglomeration as input. A clustering algorithm that groups data points based on the density of surrounding points. It takes the grouped features from feature agglomeration as input. A clustering algorithm that can identify clusters of varying densities. It takes the grouped features from feature agglomeration as input. A clustering algorithm that uses the eigenspectrum of the similarity matrix to group data points. It takes the grouped features from feature agglomeration as input. A density-based clustering algorithm that identifies clusters as regions of high density separated by regions of low density. It takes the grouped features from feature agglomeration as input.